Good afternoon.
Good afternoon.
Can we start by maybe stating your name, where you work, and the area of research?
Okay, so I'm Caroline Landry. I work in INRIA in Rennes, and I'm the field of research of my team, the diverse team in INRIA. It's code generation, modeling approach, and such of things. So test generation is part of it.
Okay. Now I understand that the project is focused on DevOps.
Yes, on DevOps and test amplification in DevOps, actually.
So how do you define DevOps in that context?
So in that context, for us, DevOps is continuous integration, continuous building software, continuous testing. The key word here is probably automation. And so what we want to address with some project, there is still some painful points you need to do manually, like, for example, writing the tests or writing the different configuration you need to test the software. And also when you deploy the software and you received a log of a crash, you need to analyze it and to have some manually hand work to replace the crash, yes. And so you need to write manually a new test case to address the crash, reproduce it, and then maybe increase your test route.
Okay. Now the project addresses, how does the project address the issues?
So those issues that are the three technical issues addressed by the project by three different partners, academic partners actually. So one is in the INRIA, the other is Saint-F, and the third one is TU Delft. And so the point is, the nice, great thing in STAMP is that we also have 4 companies as partners in the project, and they are really working and trying to include in their build chain the tools developed by the academics. So it's really a cooperation, and it's really a great thing and unusual at such as at this level in a European project.
Can you describe some of the tools that
yes,
the project
of course.
created?
So the main tools I know, it's obviously the one developed by INRIA. Okay, and so there is actually 2 tools. One that is called Descartes, that is French mathematicians. Okay, it's a tool that allow you to evaluate, to assess, and to score your test suite, and so to check if your test suite is able to detect bugs. Actually, so there is. Running Descartes, you have the code coverage, the usual you can have, and then the score mutation score. And so what is interesting is that even if you have 100% code coverage, you can have a low mutation score. And it means mutation score, if you know mutation, maybe I should explain what mutation testing is. Okay, so mutation testing is you have your source code, you test route, you change one instruction in the code. This new version of the software is called a mutant. And so you rerun the test suite, and if your test suite is still green, you kill the mutant, you keep the mutant alive, and if it's red, you kill the mutant, because the variation in the code is detected by the test suite, so it's good for your test suite. And so you do this for not every instruction, but a lot of instructions in the code. And so after that, you have the mutation score, that is the ratio between the live mutants and generated mutants. Okay, so it gives you a score. And so it's interesting to see that there is a link between line coverage and mutation score, but sometimes it can be very different, so it's a very interesting result.
Okay.
So.
And you're saying that the tools are being adopted by industry players?
Yes. So in this context, I explained what is mutation testing, and in this context, you can imagine how much time you can it needs to pass all the tests. And so what we are doing with Descartes is extreme mutation testing. That is, instead of modifying only an instruction, we remove a whole body of a method and replace it by nothing or return a constant value or something like this. That's it called extreme mutation. And so it decreases the number of mutants, of course, but this is still a huge time consuming for the machine. But at least we can try to include this in build chain. And so XWiki, that is a partner in the project, already inserted Descartes in Jenkins pipeline. Okay. Actually, currently we are also working on a GitHub application that will trigger Descartes on a pull request. And Atos, another partner, work on Eclipse plugin to integrate, to call some tools. So the final goal is to provide all those tools and microservices, and so they can be included in several different build chains. So it's already available for Despot and Descartes in Maven Central, so it's already integrated with Maven and Gradle also. And for other tools, it's coming. So.
And then, what's your time frame for completion?
So we are now at the half of the project. Mm-hmm. So we have prototypes. You can test the project, the tools. They are all available in GitHub. It's every tools are open source, and so the time frame is we really hope in 18 months to have something that can really be usable as a service.
Have you thought about what the project does after that?
No, not yet. But we have some ideas because we want to propose, another proposal to the European Commission. But we have several ideas, so we need to talk. And maybe, I don't know, for partners, some of them really want to include one of the tools or two of the tools in their product actually or service. So it will be.
Well, all right. Well, thank you for your time. This has been great, and I look forward to seeing the rest of your research or the completion of your research. And best of luck.
Yeah, thank you.